YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to work out 10 practice problems involving operations with fractions. In case this is your first time finding my YouTube channel, I quickly want to mention that I've created 4 videos on fractions so far, and if you watch all of them in this order, you should have no problem whatsoever dealing with fractions on the ASVAB. As you can see, I recommend you start by watching my 30-minute review on fractions. After that, you should watch this video. And then finally, you should watch my 2 videos in which I work on word problems involving fractions. In the description of this video, I'll include links to all these videos. And in addition, I want to mention that you can find these in my playlist for my 2021 ASVAB AFQT study guide. And of course, I'll put a link to that playlist in the description of this video as well. In order to get the most out of this video, I strongly encourage you, as I always do, to work out these problems on your own. That is to say, you should pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. So all that being said, let's go ahead and get started with today's video. All right, this first question says 1/5 divided by 1/4 squared. So for all the problems, we're going to have to make use of the order of operations. And those are best remembered by the acronym PEMDAS, P-E-M-D-A-S, or the mnemonic device, please excuse my dear Aunt Sally. This tells you the order in which you work out expressions like this. Specifically, you work out what's in parentheses first. After that, you work on exponents. After that, you work on multiplication and division as they appear in your expression from left to right. And then finally, you do addition and subtraction as they appear from left to right. That is to say, both multiplication and division, as well as addition and subtraction, have equal precedence. So with that in mind, let's take a look at this first expression. We have division here and an exponent here. So according to the order of operations, we're going to do the exponent first, and then we'll work on that division. So, and let me just write this off to the side as if it was on my own scratch paper. Get on the ASVAB, you're not permitted to use a calculator or a reference sheet, but you will have scratch paper, so you want to get used to writing these problems down and working them out. Again, the first thing I'm going to take care of is this 1/4 squared. 1/4 squared, and I'm going to work that off to the side here. 1/4 squared is the same as 1/4 times 1/4. And as you can see, we're multiplying fractions now. And when you multiply fractions, you just multiply straight across. That is, you do 1 times 1 over 4 times 4. 1 times 1, of course, is 1. 4 times 4 is 16. So 1/4 squared is 1/16. This becomes 1 over 5 divided by 1 over 16. All right, in order to divide fractions, you have to follow this algorithm. Keep, change, flip. And this refers to the order in which you work this out. You keep this first fraction the same, so we're going to keep 1/5 the same. This C, or change, refers to this division sign right here. You change it from division to multiplication. And then this flip refers to this second fraction. More specifically, it says just to flip it, so we're going to write it as 16 over 1. And as you can see, now we're multiplying these two fractions together, which means we're just going to multiply straight across as we did just a few seconds ago. So we're going to do 1 times 16 over 5 times 1. 1 times 16 is 16. 5 times 1 is 5. And as it stands, we're left with an improper fraction here. Again, an improper fraction is a fraction in which the numerator is greater than the denominator. 16, as we can see, is greater than 5. So the very next thing we want to do is rewrite this improper fraction as a mixed number. And in order to do that, we're going to perform long division. Again, you can read this as 16 over 5 or 16 divided by 5. And so now we're asking ourselves, how many times does 5 go into 16 without going over? Of course, that's 3 times. Given that 5 times 3 is 15. 16 minus 15 is 1. So now we have enough to write this as a mixed number. Again, this 3 is going to be our whole number. This 1 is going to be our numerator. And this 5 is going to be our denominator. So 1/5 divided by 1/4 squared is 3 1/5. All right, so that's that one. All right, this next one says 1/2 times 4/9 plus 2/5. To start, I'm going to copy this down over here as if it was on my own scratch paper. So we have 1/2 times 4/9 plus 2/5. And as you can see, there are only two operations in this problem, notably multiplication and addition. According to the order of operations, which I'm going to write out very quickly over here, we do multiplication before addition. So we're going to work out this multiplication here, and then we'll deal with this addition next. So as you may recall, to multiply fractions, you just multiply straight across. So this becomes 1 times 4 over 9 times 2. Of course, that's going to be plus 2/5. We haven't worked that out yet. 1 times 4 is 4. 9 times 2 is 18 plus 2/5. We can reduce this fraction right here by dividing 4 as well as 18 by 2. 4 divided by 2, of course, is 2. 18 divided by 2 is 9. And then this is plus 2/5. In order to add fractions, the denominators have to be the same. And as you can see, we have denominator of 9 here and a denominator of 5 here. So we have to find a common denominator such that we can rewrite these fractions over that common denominator. And if it's helpful, you can find that common denominator by listing out factors of both 9 and 5 until you find the same one. So let's see what that looks like. Again, we have 5, 10, 15, 20. These are factors of 5, 25, 30, 35, 40, 45. And we'll stop right there. Factors of 9, 9, 18, 27, 36, 45. And as we can see, both 5 and 9 have a common factor of 45. So we'll rewrite both these fractions such that they're over 45. In order to write 9 as 45, we would actually multiply it by 5. And we're also going to do that to its numerator. Again, 9 times 5 is 45. 5 times 2 is 10. To write 5 as 45, we're going to multiply it by 9. And we're also going to do that to its numerator. 5 times 9 is 45. 2 times 9 is 18. Now that these fractions have the same denominators, we can simply write them like this. This becomes 10 plus 18 over 45. 10 plus 18 is 28, and that's over 45. And we can't reduce this any further, so the answer to this one is 28 over 45. Okay, so that's that one. A lot of steps there, but nothing too difficult. All right, let's work on this next one. It says 1/2 cubed plus 2/3. Well, again, let's refer to the order of operations just to make sure we know what we're going to do first. Again, please excuse my dear Aunt Sally. We do exponents before addition. And in this one, we just have an exponent and addition. So we're going to do this exponent first and then the addition. But that said, to start, I'm going to copy this off to the side. We have 1/2 cubed plus 2/3. And I'm going to work this 1/2 cubed off to the side. 1/2 cubed is the same as 1/2 times 1/2 times 1/2. And again, we're just multiplying fractions, so we're just going to multiply straight across. So this becomes 1 times 1 times 1 over 2 times 2 times 2. 1 times 1 times 1 is just 1. 2 times 2 is 4, times 2 is 8. So this 1/2 cubed is 1/8. And again, now this just becomes 1/8 plus 2/3. As we can see, the denominators are different, and in order to add or subtract fractions, you have to have the same denominators. If it's helpful, I'm going to go ahead and list out the factors of 8 and 3 until we find a common denominator. As this video progresses, I'm going to stop doing that because that's something you should be able to do mentally. But that said, factors of 8 are 8, 16, 24, and that's all we're going to need for this one. Factors of 3 are 3, 9, 12, 15, 18, 21, and 24. And as we can see, both 8 and 3 have a common factor of 24. In other words, we're going to rewrite both these fractions such that they have the same denominator of 24, which is going to look like this. In order to write 8 as 24, we multiply by 3. We're also going to do that to its numerator. 8 times 3 is 24. 1 times 3 is 3. In order to write 3 as 24, we have to multiply by 8. We're also going to do that to its numerator. 3 times 8 is 24. 8 times 2 is 16. And again, this just becomes 3 plus 16 over 24. 3 plus 16 is 16, 17, 18, 19. 19 over 24. 19 is a prime number, so there's no way we can simplify or reduce this fraction any further. So the answer to this one is 19 over 24. All right, so that's that one. All right, this next one says 1/2 plus 3/5 in parentheses divided by 2/9. So if it's helpful, you can start by writing your order of operations. Again, that's PEMDAS. And according to the order of operations, you do what's in parentheses first. In this case, we do have parentheses, so we're going to work out what's in parentheses first. And then we just have division. So we're going to work on parentheses, and then we're going to perform the division next. So this becomes 1/2 plus 3/5 divided by 2/9. I'm just copying that down as if it was on my own scratch paper. So let's work out this addition here. Again, we're adding two fractions that have different denominators. So we're going to have to make an effort to rewrite them such that they have the same denominators. And in this case, it should be pretty easy to do this one mentally. Both 2 and 5 have a common denominator of 10. So to write 2 as 10, we would multiply it by 5. We're also going to do that to its numerator. Again, 5 times 2 is 10. 5 times 1 is 5. To write 5 as 10, we would multiply it by 2. And we're also going to have to do that to its numerator. 5 times 2 is 10. 3 times 2 is 6. Again, this becomes this. 5 plus 6 over 10. I'm going to move over here so I can have some room to work with. 5 plus 6 is 11, so this is 11 over 10 divided by 2 over 9. To perform this division here, we're going to follow the algorithm keep, change, flip. And that says keep this first fraction the same, so we're going to keep this as 11 over 10. We're going to change from division here to multiplication, and then we're going to flip this second fraction to be 9 over 2. Now we're just multiplying fractions, so we're just going to multiply straight across. This becomes 11 times 9 over 10 times 2. 11 times 9 is 99. 10 times 2 is 20. So the next thing we want to do is rewrite this improper fraction as a mixed number. And to do that, we're going to treat this like long division. So we're going to read it as 99 divided by 20. And the question becomes, how many times does 20 go into 99 without going over? Well, 20 times 5 would be 100, so that's too big. So this is going to be 4. 20 times 4 is 80. 99 minus 80, well, 9 minus 0 is 9. Uh, 9 minus 8 is 1. So we have enough to write our mixed number. This 4 is going to be our whole number. This 19 is going to be our numerator. And this 20 is going to be our denominator. So in other words, 1 half plus 3/5 in parentheses divided by 2 ninths is 4 and 19 over 20. Okay, so that's that one. All right, this next one says 1/6 minus 1/9 times 5/8. Again, if you need it, you can write out the order of operations to guide your work, and that's PEMDAS. And in this case, we just have two operations, notably subtraction and multiplication. Of course, multiplication and the order of operations comes before uh, subtraction here. So let's go ahead and write this one off to the side so we can have some room to work on it. Minus 1/9 times 5/8. We're going to do this multiplication before the subtraction, as I just mentioned. So in other words, we're going to multiply straight across here. And we'll just copy down this 1/6 since we're not dealing with it yet. This becomes 1 times 5 over 9 times 8. 1 times 5 is pretty easy to work out. That's just 5. 9 times 8 is 72. All right, so now we're subtracting fractions, which means we have to have the same denominators. As you can see, we have a denominator of 6 here and a denominator of 72 here. So we want to rewrite them such that they both have a common denominator. This one's not that easy to do very quickly, but if you know your times tables, you should realize that 12 times 6 is going to be 2 times 6 is 12, carry a 1. 6 times 1 is 6 plus 1, 72. So in other words, 6 and 72 have a common factor of 72. So we're going to rewrite both of them to be over 72. Again, 5 over 72 is already over 72, so we're just going to leave that as is. In order to write 6 as 72, we have to multiply it by 12. We're also going to do that to its numerator. 12 times 6 is 72, as you just saw over here. 12 times 1 is 12. So this becomes 12 minus 5 over 72. 12 minus 5, of course, is 7 over 72. 7 is a prime number, so we cannot reduce this any further. So the answer to this one is 7 over 72. All right, let's look at this next one. We have 4/9 squared divided by negative 4/5 minus 2/3. Again, if it's helpful, write down your order of operations, notably PEMDAS. There's nothing in parentheses to work out. That said, we do have exponents, we have division, and we have subtraction. So we're going to do the exponent first, the division next, and then the subtraction last. Let's start by copying this one off to the side. We have 4/9 squared divided by negative 4/5 minus 2/3. As far as this square goes, so far I've been showing you how to do this by writing it like this: 4/9 times 4/9. And that's absolutely true. But that said, if you know your laws of exponents, you could also view this like this. You can get rid of this square here and just place it here and here. So 4/9 squared is the same as 4 squared over 9 squared. So you don't have to do this amount of work. But that said, let's show that they're equal. 4 times 4 is 16. 9 times 9 is 81. 4 squared is 16. 9 squared is 81. So you can see that if you regard it like this, using the laws of exponents, that's fine. Otherwise, you can always write it out like this. Of course, this is divided by negative 4/5 minus 2/3. Let's go ahead and perform this division here before we proceed. Again, To do this division, we're going to follow the algorithm keep, change, flip. That is to say, we're going to keep this 16 over 81 the same. So that's 16 over 81. We're going to change from division to multiplication. And then we're going to flip this second fraction to be 5 over 4. Of course, this is minus 2/3 over here. We're just going to tack that on. Before we do this, we can make the math a little bit easier. Again, 16 and 4 have a common factor of 4. So 4 goes into 4 one time, 4 goes into 16 4 times. Okay. Now that we're doing multiplication, we just multiply straight across here. And let me scroll down a little bit so we can have some room to work with. Again, we're doing multiplication involving a positive and a negative, so we know our result's going to be negative. Again, a positive times a negative is a negative. This becomes 4 times 5, which is 20, over 81 times 1, which is just 81. And then, of course, we have minus 2/3 here. All right, so we've worked out our exponent. We've done the division. Now we have to do this subtraction. Trying to think if we could reduce 81 by a factor of 2. Let's see if we can do that. Let's see if 81 is divisible by 2. I don't believe it is. 2 goes into 8 evenly, so that's not going to work. Now we have to rewrite these fractions with a common denominator in order to perform this subtraction here. And again, as you can see, we have denominators of 81 and 3. So this is going to be negative 20 over 81 minus, I'm pretty sure that 3 goes into 81 evenly. And here's a little trick to test it. How do I know that 81 is divisible by 3? Well, if I sum 8 plus 1, that's 9, and 9 is divisible by 3. So if the sum of these integers is divisible by 3, then the integer itself is divisible by 3. So I'm going to work this off to the side. Again, this is 81 divided by 3. 3 goes into 8. 2 times without going over. 3 times 2 is 6. 8 minus 6 is 2. We're going to bring down this 1. 3 goes into 21 7 times. 3 times 7 is 21 with no remainder. So in other words, 3 times 27 will give you 81. And that will have the same denominator as this one. So we're going to multiply its numerator by that as well. And I'm going to work that off to the side. This is 27 times 2 here. 2 times 7 is 14, carry a 1. 2 times 2 is 4, plus 1 is 5. So this is 54 here. All right, let's keep working this out. This becomes this, negative 20 minus 54 over 81. And let me erase this very quickly here. Negative 20 minus 54, that's the same as 54 plus 20. So that's 54, 64, 74, negative 74 over 81. All right, and I don't believe we can simplify that. So the answer to this one is negative 74 over 81. All right, so that's that one. All right, this next one says parentheses negative 1/3 minus 5/6 squared divided by negative 5/9. So for this one, it's going to be helpful to write out the order of operations since there's a lot going on here. And the order of operations are PEMDAS. So let's point out what we have going on here. And before I do that, let me rewrite this so it's a little more helpful. Generally, people don't write double brackets like this. Instead, they use a big bracket like this. So this is the same as negative 1/3 minus 5/6 squared divided by negative 5/9. So in case it's not obvious, we have parentheses. Notably, we have this big set of brackets, which are parentheses. So we're going to work out what's in parentheses first, notably negative 1/3 minus 5/6. After that, we're going to work on our exponent. Notably, we're going to square what's in parentheses. Then we're just going to perform the division. So the order of this one is parentheses first, exponent next, and then division after that. So let's get to work on that. We really don't need this parentheses right here for negative 1/3 minus 5/6. But that said, we're doing subtraction of two fractions, negative 1/3 minus 5/6. So as you've seen in this video so far, we have to rewrite either one or both of these fractions such that they have a common denominator. In this one, it's pretty obvious. 3 and 6 have a common denominator of 6. So let's just go ahead and write both these fractions such that they're over 6. And before I do that, I'm just going to copy everything else down that I can. So to write 3 as 6, I would multiply it by 2. Again, 2 times 3 is 6, and I'm also going to do that to its numerator. 2 times 1 is 2. 5/6 is already over 6, so we're just going to copy that one as is. And now that these have the same denominators, we just do this. This is negative 2 minus 5/6. Of course, this is squared, divided by negative 5/9. Again, this is pretty easy to do. This becomes, and I'm going to get rid of those big brackets. Negative 2 minus 5 is negative 7/6. Again, this is squared, divided by negative 5/9. All right, so again, you could either regard this as negative 7/6 times negative 7/6, which I'm going to do off to the side, or you could just bring that square here and here. It's really up to you. But this is negative 7/6 times negative 7/6. A negative times a negative is a positive. So we know our result here is going to be positive. Specifically, it's going to be 7 times 7, which is 49, over 6 times 6, which is 36. So this negative 7/6 squared is positive 49/36. Again, it's divided by negative 5/9, and I'm going to drop those parentheses. And I'm going to start working over here now, instead of going down into the other problem. To perform this division of fractions, we're going to follow the algorithm keep, change, flip. So we're going to keep this first fraction the same. Notably, it's going to be 49/36. We're going to change from division to multiplication. And then we're going to flip this second fraction to be negative 9/5. Before we proceed, we want to simplify this a little bit more. I know 9 and 36 have a common factor. 9 goes into 9 one time. 9 goes into 36 four times. Okay, so we just reduced that. And now we have positive times a negative. Positive times a negative is going to result in a negative. This is 49 times 1 over 4 times 5. So this is negative 49/20. And let's try to write this as a mixed number. Again, we can write this as a mixed number by performing this long division here, notably 49 divided by 20. Again, we know it's going to be negative, so let's deal with that real quick. 20 goes into 49 two times without going over. Given that 2 times 20 is 40, 49 minus 40 is just 9. So this becomes 2 and 9/20. All right, so all this worked out becomes negative 2 and 9/20. We can't reduce 9/20 any further, so that's our answer in simplest terms. A lot of work, but nothing too difficult. Again, if you know how to multiply fractions, subtract fractions, divide fractions, and add fractions, you should be able to do every problem in this video pretty confidently. And we have 3 more to go. All right, this next one says 3/4 cubed times 5/9 minus 7/8. If it's helpful, you can write out your order of operations to guide your work. Again, we do what's in parentheses first. There's nothing in parentheses, but we do have exponents, notably 3/4 cubed. So we'll work on that next. Then we're going to do our multiplication, which we have right here. And then finally, we'll do our subtraction. So the order in which we're going to work on this one is exponent, multiplication, and then subtraction. And as always, I'm going to write this one off to the side as if it was on my own scratch paper here. All right, so let's take care of this exponent. There's two ways you can do this one. Again, and I'm going to do it off to the side. You can either regard 3/4 to the 3/4 cubed as 3/4 times 3/4 times 3/4, which would be 3 times 3 times 3, which is 27 over 4 times 4, which is 16. 16 times 4 is 4 times 6 is 24. Carry a 2. 4 times 1 is 4 plus 2 is 6. Can either regard this as, again, 3/4 cubed is the same as 3/4 times 3/4 times 3/4, or you could have done this. You could have written it as 3 cubed over 4 cubed, which would have been 27 over 64. That's really just your preference. And again, this one is working it out the long way. This one is using the laws of exponents to apply this cube to this 3 and 4 at the same time. And as you see, they're the same thing. So this becomes 27 over 64 times 5 over 9 minus 7 over 8. We took care of our exponents there. Before we do this multiplication here, which is the next thing we're going to do in our order of operations, we want to simplify. Notably, I know 9 goes into 9 one time, 9 goes into 27 3 times. Okay, so that simplifies that a little bit. And this becomes, as we can see, 3 times 5 over 64 times 1 minus 7 over 8. 3 times 5 is 15. 64 times 1 is going to be 64 minus 7 over 8. And now that we're doing our subtraction, we have to rewrite either one or both of these fractions such that they have the same denominators. As we can see, we have a denominator of 64 here and 8 here. Well, as it happens, we should know that 8 times 8 is 64. So it's going to be very easy to write both these fractions over 64, and I'm going to do that over here. Again, 15 over 64 is already over 64, so we're not going to make any adjustments there. To write 8 as 64, we're going to have to multiply it by 8, and we're also going to do that to its numerator. 8 times 8 is 64. 7 times 8 is 56. Now that we have the same denominator for both fractions, this becomes this, 15 minus 56 over 64. And this, believe it or not, is not that easy to do without a calculator. The way I like to do it is like this. I'm going to do 56 minus 15, and I know the result's going to be negative. Again, 15 minus 56 would be negative, but to do it by hand, you have to do it like this over here. 6 minus 5 is 1. 5 minus 1 is 4. So this is 41, negative 41 over 64. 41 is a prime number, so you can't reduce this any further. So this is negative 41 over 64. All right, so that's that one. All right, so this next one says 2/3 squared times parentheses 5/6 divided by 2/5 minus 1/4. So if it's helpful, you can put your order of operations here. And of course, we're going to work on what's in parentheses first. And we do have a set of parentheses in this problem. It's right here. And more specifically, once we're inside that set of parentheses, you can think of the order of operations as starting over. So inside this parentheses, we have division here and subtraction here. So in the parentheses, we're going to do this division first and then this subtraction. Once we work out what's in parentheses, we'll come back and do the exponent over here. So to start, let's copy this down as if it was on scratch paper. We have 2/3 times squared times 5/6 divided by 2/5 minus 1/4. Again, let's work on what's in parentheses first, and we're going to work on the order of we're going to follow the order of operations inside the parentheses itself. So this is 2/3 squared times, again, we're going to do this division before this subtraction according to the order of operations. So this is going to become 5/6. And again, we're following the algorithm keep, change, flip to perform this division here. So instead of being division, this becomes multiplication. Again, keep this first fraction the same, which I did, change from division to multiplication, which I did, and then flip this second fraction to be 5/2. And this is minus 1/4 over here. Let's keep working this one out. Again, we're just multiplying fractions here, so we're going to multiply straight across. And I'm not going to work this one out because we should be able to do this mentally by this point in the video. This is 5 times 5, which is 25, 6 times 2, which is 12. So this is 25/12 minus 1/4. We're still working in our parentheses. We took care of this division inside this parentheses, but now we have to take care of this subtraction. So again, this is 2/3 squared times, and again, we're performing the subtraction of two fractions. In order to do that, we have to rewrite either one or both of the fractions such that they have the same denominators. As we can see, we have denominators of 12 and 4. Well, this one's pretty easy to do mentally. We can write 4 to have a denominator of 12 pretty easily by multiplying it by 3. Again, 4 times 3 is 12. We're also going to do that to its numerator. 1 times 3 is 3. So 1/4 is the same as 3/12. And we're just going to copy this one down as is. I'm going to start moving over here to finish this one. So again, this is 2/3 squared times, and let's do this subtraction here. This becomes 25 minus 3/12. This is 2/3 squared times, what's 25 minus 3? That's going to be 22/12. And if we want, we can reduce 22/12 pretty easily. Both 22 and 12 are divisible by 12, or by 2. So this becomes 2/3 squared times 22 divided by 2 is 11. 12 divided by 2 is 6. Okay, so now that we've taken care of our parentheses and our division and subtraction inside that parentheses, let's go ahead and deal with this exponent now. Again, I'm going to do this one very quickly using the laws of exponents. Again, this squared applies to this 2 as well as this 3. So 2/3 squared is the same as 2 squared over 3 squared. 2 squared is 4. 3 squared is 9. So this is 4/9 times 11/6. And if you want to reduce this one before proceeding, you can do 2 goes into 4 2 times, 2 goes into 3 or 6 3 times. And now we can proceed. Again, we're just multiplying fractions here. So this becomes, and let me see if I can move over to the left. I don't think I can, so I'm just going to keep moving down. This becomes 2 times 11, which is 22, over 9 times 3, which is 27. So the answer to this one is 22/27. We can't reduce this any further, so we're going to stop right there. All right, so that's that one. All right, so finally we have 2 and 2 ninths times negative 1 and 1/3 plus negative 1 and 7 ninths plus 0.75. So if it's helpful, you should write down your order of operations, notably PEMDAS. And in this one, it's not that difficult to figure out how we're going to work this one out. We have multiplication here, addition here, and addition here. So we're going to do our multiplication first, followed by our addition. And what's more, we're going to do addition all at the same time. So that said, there are some tricky parts to this problem. First, you should see that we're dealing with mixed numbers as well as decimals in this case. So we're going to have to rewrite these mixed numbers as improper fractions. And likewise, we're going to have to write this decimal as a fraction as well. So let's get started doing that. First, I'm going to copy down the problem though. So this is 2 and 2 ninths times, and I'm going to get rid of that parentheses there, times 1 and 1/3 negative plus and again, instead of regarding this as plus negative 1 and 7 ninths, I'm just going to write minus 1 and 7 ninths plus 0.75. All right, so let's rewrite these mixed numbers as improper fractions, and let's write this decimal as a fraction as well. To write this improper or this mixed number as an improper fraction, we're going to do 2 times 9, which is 18, plus 2, that's going to be 20 over 9 minus, and let's do the same thing here. 1 times 3 is 3 plus 1 is 4, so this is 4 over 3 minus 1 times 9 is 9 plus 7, that's going to be 16 over 9 plus 0.75, you should know, is the same as 3/4. Okay? All right, now that we've done that, and again, I dropped my multiply sign there, so let's add that back in. Now that we've done that, let's go ahead and take care of this multiplication very quickly. Again, we're just working right here, and we're disregarding this other part right now. So this becomes 20 times 4 over 9 times 3. And this 4 is technically negative, so let's write that in. Again, this is minus 16 over 9 plus 3 over 4. 20 times negative 4 is going to be negative 80 over 9 times 3, which is 27. Again, minus 16 over 9 plus 3 over 4. Now, if we really wanted to, and it's not a bad idea to consider doing this, we can rewrite all these fractions right now with the same denominators and perform this subtraction and addition at the same time. The only problem we have here is we have to find a common denominator between 27, 9, and 4. Well, I know 9 and 4 have a common factor of 36, whereas 9 and 27 have a common factor of 27. So this one's not that easy to do. Instead, I'm going to see what 27 times 4 is and see if that's divisible by 9. 7 times 4 is 28, carry a 2. 4 times 4 times 2 is 8 plus 2 is 108. So I know 27 and 4 share a common factor of 108. Does 9 go into 108? Well, let's see. 9 goes into 10 one time without going over. 9 times 1 is 9. 10 minus 9 is 1. Drop down this 8. 9 goes into 18 two times. So 27 and 4 share a common factor of 108, and 9 also goes into 108 12 times. So we're going to rewrite all these fractions such that they have a common denominator of 108. All right, so let's go ahead and work on doing that. Again, to write 27 as 108, we have to multiply it by 4. We're also going to do that to its numerator. Again, 4 times 27 is 108. Negative 80 times 4 is going to be, well, 8 times 4 is 32. Therefore, 80 times 4 is negative 320. To write 9 as 108, we had to multiply it by 12. We're also going to have to do that to its numerator here. So this is going to be 16 times 12, which I'm going to work off to the side so I don't make any mistakes. 2 times 6 is 12, carry a 1. 1 times 2 is 2, plus 1 is 3. Add a 0 placeholder before we start multiplication with that 1. 1 times 6 is 6, 1 times 1 is 1. 2 plus 0 is 2. 3 plus 6 is 9. 1 plus nothing is 1. So this is 192 here. To write 4 as 108, we had to multiply it by 27. So we're going to do that to its numerator as well. And so as not to make any mistakes, I'm just going to work it off to the side here. 7 times 3 is 21. So bring down a 1, carry a 2. 2 times 3 is 6, plus 2 is 8. So this is 81. And let me get rid of this real quickly so I can have some room to write the rest of the solution out. So let's combine this. Again, this is all going to be over 108. We have negative 320 minus 192 plus 81. What I'm going to do is combine these two right now, and that's going to be negative 320 and negative 192. We're adding those together, so we know our result's going to be negative. 0 plus 2 is 2, 9, 10, 11, carry a 1. 3 and 1 is 4, plus 1 is 5, so this is negative 5 twelfths over 108 plus 81. And now we have to work out this. Again, this is negative 5 twelfths plus 81. The way I'm going to do it is like this. 512 minus 81. But I know my result's going to be negative. All right. So 1 minus 2 is 1. 8 minus 1 we can't do, so we have to borrow. This becomes 4. This becomes 11. 8, 9, 10, 11. That's going to be 3. And that's 4. So this is 431 over 108. All right. Let me just say this before I end. You could write this as a mixed number as well. Again, you would say, how many times does 108 go into 431? In other words, what is 431 divided by 108? Well, we know the answer to this one is going to be 3. And let's work that off to the side. 108 times 3. 3 times 8 is 24, so drop down to 4, carry a 2. 0 times 3 is 0, plus 2 is 2. 1 times 3 is 3. If we multiplied 108 by 4, it would have been 432, which is too big, so we can't do that one. So this is 324. 4 minus 1 we can't do. We have to borrow. This becomes 2. This becomes 10 or 11. 11 minus 4 is going to be 7. 2 minus 2 is 0. And 4 minus 3 is 1. So if we were to write this as a mixed number, it would be 3 and 107 over 108. Of course, this is negative. But I think if you got negative 431 over 108, given the amount of work for this one, that's fine as well. But that is it for this video. I hope you found it helpful. As you can see, these problems took a lot of tedious work to solve. But that said, this is great practice for the ASVAB because you never know what you're going to see on there. And according to a lot of comments I've gotten recently, a lot of people have had to deal with fractions. So again, if you watch these 4 videos on fractions, you'll be good to go for test day. As usual, you're more than welcome to leave feedback in the comment section below. What's more, if you like the content I'm creating, please consider subscribing to my channel. That always helps me out. But on that note, I'm going to go ahead and cut you loose.